Alright, look at this question. A photocell with cathode and anode made of the same metal connected in a circuit as shown in the figure below. Monochromatic light of wavelength 365 nanometer. Again, look at the unit nanometer. Okay, shines on the cathode. Cathode is the metal surface. Yeah, remember the cathode is the metal surface. Metal surface, which cathode, we need to investigate their work function. They have their own work function, they have their own threshold frequency, and also their own threshold wavelength. Okay, and the photocurrent is measured for various value of voltage across the cathode and anode. So for various, the current, yeah, find the photocurrent for various voltage, the current versus voltage. And this is the result. We got this. Okay, first of all, okay, we have the wavelength here. It gives us the wavelength. This is the lambda. Okay, give us the wavelength. Yeah, we have the wavelength here. This is the wavelength of the incident. This is the incident photon. Wavelength of the incident photon. This lambda, which will help us to find the energy of incident photon using hc over lambda. If we have frequency, then we use hf. But lambda is given. So we just use hc over lambda. That's we can find energy of incident photon. Now, about this graph, you must pay attention to what is this value. What is this -1 means? What is this 5 means? What they representing? This is very important. And then also need to pay attention at the unit. You see, this is nano. Nano, this is a -9, exponent -9 ampere. Okay. So this is actually 5 nanoampere, not 5 ampere. 5 exponent -9 ampere. And then what is this value again? What is this representing? This is the saturation current, the maximum current that can flow through when all the photoelectrons ejected reach the anode. So this is the saturation current. This is called the IM, the maximum, or we call it the saturation. This is the saturation current. Yeah. Make my writing a bit nicer. Saturation current. That's the Imax. IM. Okay. And then what is this -1? This -1 happens at when current equal to 0 ampere, isn't it? You see, when current drop to 0, that means this is the stopping potential. Stopping potential will cause all the electrons cannot reach the anode. So that's why no more current detected by galvanometer. This is what we call the stopping potential. Stopping voltage, stopping Vs. This is the Vs. Okay, the stopping potential or stopping voltage. This value is very important. You must know what is this 5, what is this -1 means. This is the saturation current IM. This is the stopping voltage -1. It has a negative value because it's reverse. Okay, you must know what this mean. Yeah, this is the stopping potential. Stopping potential when current 0. Okay, so now what is find the maximum kinetic energy of the photoelectron. Maximum kinetic energy, Kmax. How to find Kmax? Kmax actually is related to the stopping voltage, EVS, which is we already have the Vs here, -1. So just substitute here, you can find the Kmax. Okay, so let's work it out. Okay, over here. Okay, these are the information given: the wavelength, the saturation current, the stopping voltage, which is -1, current when voltage when current equal to 0. Okay, want to find the Kmax is EVS. EVS. So remember, don't just ignore this one. Just ignore the negative sign. Yeah, just ignore the negative sign for calculation during calculation only. Yeah, during calculation only. But when asked for finding the final answer, stopping voltage, you need to give negative sign. Yeah, you need to put negative sign. So okay, so Kmax is electron charge, which is 1.6 exponent negative 19. Okay, and then stopping voltage is just ignore the negative sign, just put 1 volt. Just put 1 volt. Yeah, just put positive 1. And then, so what's the multiply 1? Surely you get Kmax equal to 1.6 exponent negative 19. Also, joule, the unit in joule, okay, in SI unit. In SI unit. Okay, so that's it for this Kmax. Okay, so now find the work function. We need to find the work function for the cathode. So what's the work function for the cathode? What's the work function for this cathode? To find the work function, we need to use the photoelectric equation. E equal to Kmax plus work function. So we already have the Kmax, isn't it? Kmax, and also he give us the wavelength lambda. Give us the wavelength lambda. You see, this lambda can help us to find the energy of incident photon E. So we already have the Kmax and also have the E. Then we can find the work function, but we only have the Kmax only, but we don't have the energy of incident photon yet. We need to calculate. Use the Hc over lambda. Okay, energy of incident photon. Right? Okay, let's calculate energy of incident photon. So E is equal to H. H is a 6.63 exponent negative 34. And then C is 3 exponent 8. 3 exponent 8. And then lambda, what is lambda? Lambda is lambda. What is the lambda given? 365 nanometer. Okay, 365. 365. Okay, 365 nanometer, negative 9. Okay, 365 nanometer. All right. Okay, so I can calculate. So what's my energy I get? Yeah, what's my energy I get? Energy I get is let me see. What's the energy I get? It is a 3 point. No. This energy I get. I don't have the answer here, but never mind. Just calculate using my calculator, and then what's the answer? Okay, let me calculate and see. Okay. So what's the answer I get? It is 5.44. No. 5.45. 5.45 exponent. Oh wait. Let me see. Maybe I calculated wrongly. Okay. So the answer I get is actually 5.45 exponent exponent negative 19. Negative 19 joule. So also I get the unit in joule. Yeah, I get the unit in joule, SI unit. Yeah, SI unit. This one I get in SI unit also. Right. So that's the energy of incident photon. Okay, in unit in joule. Whatever this information, whatever this information. Kinetic energy, okay, this formula EVS, I surely get joule. The Hc over lambda, I surely get the SI unit joule also. Yeah, all the unit from all the equation, you usually get the SI unit first. You won't get electron volt. Okay, you won't get electron volt. So now, to find the work function, I also get the answer in joule. All right. So let us substitute and see. The energy of incident photon is 5.45 exponent negative 19, and then equal to the Kmax is a 1.6 exponent negative. Okay, let me show you. Exponent negative 19 and plus the work function. So what's the work function? What is the work function? Let me calculate. Let me calculate and see. Okay, so the answer for work function I got is 3.85 exponent negative 19 joule. Is that correct? Is that correct answer? Yeah. The answer is 3.85 exponent negative 19 joule. Yes, that's correct. Okay, that's the work function. Okay, so that's a deduce work function. If the question specifically asks you to find the work function in electron volt, then you got the unit in joule, then only you want to convert to electron volt. Then now you can convert to electron volt. How to convert to electron volt again? Yeah, remember again how do I convert the unit from electron volt to joule? Remember? Still remember? Yeah, convert from electron volt to joule is multiply electron charge. From joule to electron volt, I divide by electron charge. Remember that? To convert to electron volt, I divide by electron charge. To convert to electron volt, I divide by electron charge. Then you can get your work function in electron volt. Maybe I can show you how to divide to electron volt. Exponent negative 19. So the answer I get is 2.406, which is 2.41 electron volt. So if the question specifically asks you to find work function in electron volt, you can convert the unit from joule to electron volt finally. Okay, by divide electron charge, you get electron volt. Just remember this process lah. Electron volt to joule, multiply electron. Joule to electron volt is divide by electron. That's it. Yeah. Make sure when you use this equation, this formula will surely give you joule first. Will surely give you the unit joule first. This equation will give you joule. Then when you substitute into this equation, make sure you maintain the same unit. All you maintain the same unit. All you must use the same unit. Don't go to different unit. Yeah, joule, electron volt, joule cannot. Yeah, you must joule. Or you want to maintain all electron volt also can. Yeah. Make sure they have the consistent unit. Okay. Now, let me. If the experiment is repeated, okay, look at the final question. If the experiment is repeated with a monochromatic light of wavelength 313 nanometer, determine the new intercept with the volt axis, with the v-axis for the new graph. So now we have lambda 2 here. We want to find the new intercept. I just want to rub this off, yeah, because it's a bit messy already. So now I have lambda 2. Okay, I need to find the new intercept at the volt axis. That means I want to find the intercept at this volt axis. What does it mean, this intercept? The stopping voltage. So I need to find the just want to rub this off, yeah. Okay, the new intercept for volt axis is the stopping voltage. So we need to find we consider this is the Vs2. We need to find the Vs2, the stopping voltage for the lambda 2. Understand? We want to find the stopping voltage for lambda 2, the intercept for V axis, which is the stopping voltage for lambda 2. So how? If you use a new wavelength, there will be new energy of photon. Yeah. So this will have a new energy of photon, Hc over lambda. Yeah. If you are using lambda 2, then you have a new energy of photon. But this one still maintain the same metal, right? So the work function still constant because you are still using the same cathode. You're using the same cathode. Okay. You are using the same cathode. So the work function is still constant. So you can use back the value work function just now, 3.85 exponent negative 19, because you still use the same cathode. Yeah. Same cathode, same work function, same metal. So what different is just the energy of photon. Different. and then you will have if energy of photon different, the Kmax also different lah. Okay, so first of all, we need to find the energy of the new photon. So substitute, substitute. H is 6.63 exponent negative 34, and then speed of light is 3 exponent 8, and then lambda, what is lambda? Let me give the lambda. 313 nanometer. 313 nano is negative 9. 313 nanometer. So what is the energy of photon? 6.63 exponent negative 34 multiply 3 exponent 8 divide by 313 exponent negative 9. So what is the answer? The answer is 6.355 3.355 exponent negative 19 joule. That's the answer, joule. Okay, so I can substitute into the formula. Okay, I can substitute into this formula, and what's the answer I get? Okay, so the energy of photon is this one. So the new energy 355 exponent negative 19. So what is the and then what's the kinetic energy? What's the kinetic energy? And then work function, use the same cathode, same metal, because we just change the radiation, we just change the wave, we don't change the metal, we use back the same cathode. So this is 3.85 exponent negative 19. Use the joule, maintain all the unit in joule. Make sure all in joule. The final answer work function also joule. Okay, so this work function also must use the one joule, not use the electron volt. 3.85 exponent negative 19. This one also in joule. Understand? Joule. So okay, so what is the Kmax? So what's the Kmax? Okay, so minus this 3.85 exponent negative 19. So we will get the answer. Kmax is equal to 2.5046 exponent negative 19 joule. That's the Kmax. But the question asks for the stopping voltage. Stopping voltage is related to the Kmax. So we can use the Kmax equal to EVS. So we can find the stopping voltage. Okay, so Kmax, so this equation 2.5046 exponent negative 19 equal to E. What is E? Electron charge is 1.6 exponent negative 19 electron charge multiplied by the stopping voltage. So Vs is equal to so what's the answer? Divide by 1.6 exponent negative 19. So the final answer is the stopping voltage is 1.565, which is 1.57 volt. So the stopping voltage is 1.57. Is that correct? Wrong. You still miss one step. Now he wants the stopping voltage as the final answer. So it's not a positive value. You need to rewrite the stopping voltage as negative value, which is negative 1.57 volt. You need to put a negative sign, because why? Because it is a reverse voltage. So remember the final answer. Okay, the final answer, remember this final answer for stopping voltage or stopping potential, okay, must have negative sign. We only ignore the negative sign during calculation. We only ignore the negative sign for stopping voltage during calculation. Like stopping voltage is negative 1 volt. We just put as positive 1 volt here for calculation. But for final answer like this one, the stopping voltage for the lambda 2, we need to put a negative sign, yeah, as the final answer for stopping voltage. Final answer for stopping voltage, you must include the negative sign because it is a reverse voltage. It is a reverse voltage. Okay, so must put a negative sign. Okay, so is that correct? The answer, is the answer correct? Yes. So it is correct. Negative 1.57. Yeah. So that's the intercept. We can say the intercept for the new intercept for the v-axis is the stopping voltage, which is negative 1.57. Yeah, negative 1.57 volt. That's a new intercept, or is negative 1.57 volt. Okay, rewrite this one lah. Okay, so that's all for this question. Okay, thank you for watching, and if you don't have anything you don't understand, you can just leave a comment below. Yeah, see you again in the next chapter.